Okay, excuse me, finite math students. We're going to work on some more homework problems in your chapter 3 homework. This time, let's focus more on the present value and mortgage problems. I certainly do not have the time to go through every single one of those problems. But we can go through a nice sample of those problems so that you get a general idea of how you would use Mathematica to solve those problems. Okay, so let's see. Here we go. Okay, so let's take a look at problem 137 in your current homework assignments. Okay, let's see. A family has, here, 1 second. This is problem 137, okay, of your chapter 3 homework assignments. Just making sure everyone can see that. Okay, a family has a $128,742 30-year mortgage at 7.5% compounded monthly. Find the monthly payments. Also find the unpaid balance after the following periods of time: 10 years, 20 years, and 25 years. Okay, excuse me. So again, I have to emphasize, guys, that I'm showing you my way of solving these problems. If you don't understand my approach, that's fine. Then use the approach in the textbook. I'm showing you an alternative approach that will help you arrive at exactly the same answer. Use whichever approach is going to work for you. If, for whatever reason, you don't like Mathematica, then use Microsoft Excel, or use Apple's numbers program, or use your calculator. Use whatever it takes to get the job done. My preferred computational tool is Mathematica. That's what I teach. That's what I know. That's what I really like to use. Hopefully you like it too, but if you don't, oh well, then use another computational tool. It's your choice. All right? Okay. However, remember this. If you want my help, if you're going to request a video conference with me, then we're going to be using Mathematica during the video conference. If you're going to use your Texas Instruments calculator or Excel or Numbers or QuickBooks or some other software, you're going to be on your own with that stuff. I'm not going to help you with it. The only software tool that I'm going to help you with is Mathematica. Okay? All right, so enough preaching. Let's talk about the math. Okay, so first of all, 7.5%. Okay, let's do interest is equal to 7.5% divided by 1,200. Oh, can't forget to add the 1. Okay, so this is my monthly rate. This is my monthly interest rate. And we need to create a function that represents this problem. So I'm going to call it balance. And balance is a function whose argument is the number of months. All right? So that's going to be interest times the previous month's balance, whatever that is, minus my payments. And you know what? Just to make my life easier, we should expand it. Semicolon. And at time 0, at month 0, what I actually owe What I actually owe is $128,742. Semicolon, shift enter. Actually, the semicolon at the very end is optional, but in this case, I strongly recommend it. Okay, shift enter. Okay, so this function represents the problem. This function represents the problem. It's a 30-year mortgage. Right over here, I can see it's a 30-year mortgage. Okay, so how many months are there in 30 years? There are 360 months in 30 years. Okay, so balance 360. So this is my resulting equation. Now remember, after 360 months, my balance is going to be 0. After 360 months, my balance is going to be 0. I just want to see one thing very quickly. Hold on. Find the monthly, also find the unpaid balance. Okay. Okay, so my balance after 360 months is going to have to be $0. Okay? So solve. Balance 360 is equal to 0. What is my payment? So my actual payment is going to be $918. Round to the nearest cent as needed. And let's see if that's correct. Okay, that is correct. Okay, so the unpaid balance after 10 years or 120 months is, now this is going to be kind of a tricky thing. It depends on what they're asking. I believe, hold on one second. So I believe, hold on just one second. I believe what they're simply asking is, what is the balance after 10 years, which is 120 months? So that means balance, 10 times 12, which is 120, of course. All right, right? But we have to do a substitution. We know that the payment is $900.18. So balance 120, where the payment is equal to payment as it's defined on this line. And for me, that's going to be output 5. For me, that's going to be, that's going to be output 5. Which is $111,741.60. $111,741,060. Let me make sure this is what they actually want. Yes, it is what they want. Now, by the way, if you're confused by what I just did, you shouldn't be confused. Look, what if I do this in Mathematica? X plus y. Now, what if I do this? X plus y, where x is 3 and y is 4. What do you think that's going to be? That's going to be 7, because 3 plus 4 is 7. Okay. Now look over here. This is output number 9, right? Okay. So what is output number 9? Output number 9 is 7. So really, I know Mathematica may seem confusing to you guys, but it's really not that hard. I mean, I'm not saying it's that easy, but it's really not that hard either. There's a lot of stuff out there that is way harder than Mathematica, okay? Mathematica, I'm not saying Mathematica is easy, but it's really not that hard. The unpaid balance after 20 years, so 20 times 12 is 240. So balance 240, where the payment is payment as it's defined on, again, I'm just going to say, line 5. This is line 5 right here. Okay. So line 5, shift enter. So that's going to be $75,835.66. Okay. And then after 25 years, 25 times 12, so there are 300 months in 25 years. Balance of 300, payment, where the payment is defined on line 5. For me, it's line 5. For you, it might be something else, right? This is line 5. Okay, and it's going to be $44,923.90. And it should be okay. Okay. Let me see. Problem number 138, a fun problem to do. A family has a $131,710 30-year mortgage at 6% compounded monthly. So part A, find the monthly payment and the total interest paid. Part B, suppose the family decides to add an extra $100 to its mortgage payment each month, starting with the very first payment. How long will it take the family to pay off the mortgage? How much interest will the family save? Okay, again, it's a little bit of a challenging problem, but it's not that bad. It's really not that bad. So, first of all, let's clear interest and balance. Why am I clearing them? Because I'm starting over with a brand new problem. So interest is equal to 1 plus 6 divided by 1200. Okay, but I'm getting a fraction. That's not what I want. So what I could do is this. Okay, 2 forward slashes and a capital N, and that turns it into a decimal, a floating point number, which is what I want. Okay. Balance month is equal to the interest times the balance of the previous month minus my payment. And notice I don't have to clear payment here. I don't have to clear payment, right? I don't have to clear payment because payment was never really defined. Okay? And then balance of 0. For this one, it's really, for this one you should use colon equals. For this one, it really doesn't matter if you use colon equals or equals. For this one, you could go ahead and just use the regular equal sign. $131,710, semicolon. Oh, you know what I'm going to do? Hold on one second. Let's expand this expression. Let's expand that expression. Okay, so we expanded it. Let's see. 360 months. Balance 360 months, which is the same as 30 years. Okay, so now we have to figure out what is the payment. And remember, when you're done paying this off, you're going to owe $0, right? You're going to owe 0. So set this equal to 0. Balance 360 is equal to 0. Now, what is my payment? The payment is going to be about $789.67. The payment is going to be about $789.67. The monthly payment, $789.67. And it should be correct. What is the total interest paid? Okay, so you borrowed this much money, $131,710. But what are you actually paying? 360 times $789.67. 360, so every month you're writing a check for $789.67, and you're doing that for 360 months, minus what you actually borrowed, right? What you actually borrowed was that much money, $131,710, right? So that means this is my total interest. The total interest is going to be $152,571.20. $152,571.20. Okay. Excuse me. So now the next question, suppose the family decides to add an extra $100 to its mortgage payment each month, starting with the very first payment. How long will it take the family to actually pay off the mortgage? How much interest will the family save? Now for this one, what I'm going to do is this. I'm going to define payment to be 100 plus payment as it's defined on output line 23. And why am I doing that? Because this is line 23. This is line 23. All right. So the answer is $889 and some change. Okay, that's going to actually be my payment. So then I'm going to have to make a table. And I want to know, when do I actually reach 0? Because when you reach 0, you're done paying off your mortgage. When you reach 0, that means you owe $0. Excuse me, you owe $0 when you're done paying off your debts. You owe $0, okay? So how are we gonna do this? How are we supposed to do this? Well, table. We could use month as the variable. Balance of month, where month is gonna go from 0 to 360. Okay. So when do we actually reach 0? It's not going to be 360. It's going to be sooner. It's because we're paying an extra $100 every month. Okay, we're paying an extra $100 every month. So we can see here, it's going to be, hold on one second. I wonder if I could make that a little bit thicker. Okay, maybe that would be thick enough. Okay, so right over here, you can see that after about 270 months, your balance is zero. You owe $0. And so rather than paying off your mortgage after 360 months, you've paid off your mortgage after 270 months. Now, the problem is this. I know Pearson really wants it wants this to be exactly zero. So we're going to have to do something called linear interpolation. So the answer is actually going to be between 270 and 271. It's going to be like 270 point something. All right, so we're going to have to do some linear interpolation here. So here's the deal. How do you do linear interpolation? So, wait a minute, what is this? Here we go. Balance 0 and balance, oh, wait a minute, sorry. That's balance 270 and then balance 271. So you guys should remember how to do this, right? I have to find the equation of the line. How do you find the equation of a line? Well, it's going to be y is equal to mx plus b. So how do I find the slope? Here, let me write this over here. You know what? Let me write this over here. Y is equal to mx plus b. Okay. So these are the points. These are my 2 points. And I need to find the equation of this line. So I need to find the slope and the y-intercept. So how do I figure out my slope? My slope is going to be equal to balance 271 minus balance 270, right? Divided by 271 minus 270, which is just 1. That's actually the same thing as 1, so if we divide by 1, nothing changes, right? So it's actually just going to be balance of 271 minus balance of 270. Okay, so that's going to be the slope of the line. Now, how do I figure out b? Well, let's go over here. So b is going to be equal to y minus mx, okay? So b, or my intercept is going to be equal to, let's pick a y value, balance of 271, or I could use balance of 270, it doesn't really matter, minus the slope times 271. Okay, so now I have to figure out, where is this equal to 0? Where is this going to be equal to 0? So solve slope times the month plus intercept is equal to 0, and what is the month? So 270.2569, etc., etc. Okay, so I'm going to declare that variable. M is equal to month as it's defined on output line 34. Excuse me. Now, how am I supposed to actually change that into years? How do you change the number of months into years? You divide by 12. So M divided by 12, and that's going to be equal to 22.52. 22.52 years. 1 second. 22.52 years. Now the total interest that you're saving, excuse me, the total interest that you're going to save is, let's see. Now this one, again, it's, hold on 1 second, because this can be a little bit tricky. Okay, so this one, we can see from over here, we can see from over here, after 270 months, you're actually done. You're actually done with your payments, but they're actually using. They're not using 270. They're actually using. They're actually using this figure of 270.2569, etc., etc. So that's actually what we're going to have to use. So your payment is $889 and some change. Your payment times M minus balance 0. Okay, so this is actually going to be your interest. This is actually what you're going to pay in interest. I see. And then this value right over here, this is the original interest. The original interest is $152,571.20. So then 152, well, how do we get that value? Let me see, hold on 1 second. Well, I'll just copy the value. I'm just going to copy it. $152,571.20 minus payment times M minus balance of 0. Something doesn't seem quite right. Wait a minute. That's way too, wait a minute. Something got screwed up. Hold on 1 second. Payment times M minus balance of 0 is equal to $108,728.93. Yeah, that's really, so all I want to do is subtract this number here from $152,571.20. That's not negative $219,577. So that's a little crazy. So something, wait a minute, that's kind of, that is a little bit weird. Hold on 1 second. There we go. I needed to use parentheses. That was a little, yeah, that was a little bit weird. So that was a little bit strange. Or, yeah, that's fine. We'll just do it like that. So let me just copy this right over here. That was a little strange. Let me just copy that. Oops, sorry. There we go. Okay, so the total interest that you would save is $43,842.27. $43,842.27 is how much interest you will save if you pay an additional $100 every month. Okay, so that is correct. So yeah, you're going to have to use parentheses. That's kind of, interesting there. Yeah, that is definitely kind of interesting. So you need, yeah, and it actually, okay, it does make sense because otherwise, you, this number minus this value, but you're actually doing this subtraction first, which explains why you would need the parentheses. Okay, that actually makes a lot of sense. So if you don't use parentheses, excuse me, then you're actually doing this subtraction first. But you need the parentheses because what you want to do is this subtraction first rather than this subtraction first. So actually that makes a lot of sense. So that's why you do need the parentheses. All right, let's see. How much time have we used? It's about 30 minutes. Okay, guys, you know what? That's going to be enough for right now. I'm going to make another video this week showing you how to solve a few more of these problems. Right now, I think, that's really going to be enough for right now. Okay. But yeah, so just remember when you're figuring out the total interest, you really do need parentheses because otherwise you will get the wrong answer. 152,571.20 minus the payment times m minus the balance of 0. You're actually doing this subtraction first, and that's going to give you definitely the wrong answer. All right, so what you really want is 152,571.20 minus payment times m minus balance of 0. And that's going to be the correct answer. That's going to be the answer that you want. All right, guys, so I'm going to call it quits for now. I really don't want this video to get outrageously long. I will do another video for you this week showing you how to solve a few more of these problems. All right, but in the meantime, please continue working on your homework assignment. Excuse me. These are very important problems. They will definitely appear on your quiz and also your test for Chapter 3. Okay? And that's it for now. We will communicate at some point in the future, okay? Take care. Bye-bye.